All right, so we'll start on 2.7 now. 2.7 is all about inequalities. There's really one huge difference that you need to know, and then the rest is kind of just language and ideas and new symbols. But there's really only one like big, huge kind of golden rule, and we'll talk about that. So, yeah. Oh, right. Okay. 2.7. Solving linear inequalities. Alright, so what is an inequality? An inequality literally means not equal to. So generally we are using less than or equal to, greater than or equal to. So technically is also an inequality. It's just not a very useful one. I mean, it definitely is super useful in the big picture, but I mean, if they said solve like x is not equal to something, all you're basically saying is x is not equal to 5. But everything else is a solution. That doesn't really narrow it down very much. So we're going to use inequality. An example of an inequality is x is greater than 2. Okay. So what this means is on the real number line, we have a fence post at 2. Whoops. Okay, so starting at 2, we have a little fence post here, and everything on this side is an answer. Solutions. Not solutions. Okay? So it's like saying on the number line, which again, only goes backwards or forwards, there's no sideways going around. So every number is always greater than or less than. What an inequality says is, here's a stake in the ground. Everything on that side of the stake is a solution. Everything on this side is not. Okay? And then the one other detail is the fence post a solution? Yeah, it is, or no, it's not. Okay? But that's the big idea. That's what we're solving for here. We solve it the same way to get x equals to. X is greater than 2. We still need to find where is that fence post, and that's the whole solving part. The whole solving part is whittle it down, parentheses, combine like terms, add, subtract, divide. X is greater than 2. Yeah, we solved it. And then the last steps are representing it visually on a number line and even in another format, interval notation. Okay? So, and I go right here. Just to emphasize that, I could ask you on the test, and I say, hey, is x equals 0 a solution of this inequality? No, it's not in the shaded region. It is not, if I plugged it in, true. 0 is greater than 2, not true, not a solution, right? So is x equals 100 a solution? Yeah. What about x equals pi? Yeah, so any number that I can plug in that has a true statement here, that's a solution. So if I plug in pi, true. If I plug in 100, true. So there's an infinite number of solutions. That's very different than solving our equations where there's one solution usually. Sometimes there's more, but usually just one. All right. So that's a big idea. Okay. Being which to go first. I'll give you the big picture thing first. The big idea. Another big idea. you solve these exactly the same as a linear equation with one exception, and only one exception. Okay, and that exception is, if you multiply or divide both sides of the equation, inequality, by a negative number, the inequality sign changes direction. Okay, so just to give you a quick example, here's two x plus 5 equals 13. Okay, how would you solve it when there's an equal sign? Yeah, we subtract 5, we get, canceling this, 2x is equal to 8, and then?
Divide by 2.
Yeah, divide by 2, divide by 2, x equals 4, right? Going over to here, what if we changed it to 2x plus 5 is less than 13? Well, we're going to do the exact same steps. We're going to subtract 5. Did we multiply or divide both sides by a negative? Nope, so nothing happens, just normal. 2x is less than 8. Then we're going to divide by 2. Did we multiply or divide by a negative? No, so it's just normal. So it's just x is less than 4. So again, that's why section 2.3 is just the most important section in this class. You are solving every single inequality, 2.3, 2.3, 2.3, exact same steps, 2.3, over and over. Everything linear, linear equations, linear inequalities, linear equations in two variables. You're doing the same process of moving variables to one side, numbers to the other, dividing both sides by coefficient, okay? The exception is, here's example number 2. The exception is, what if I have negative 2x plus 1 equals 7? Okay, whoops, sorry, I meant to do less than. Right, so how would I solve this?
Subtract 1.
Yeah, same process, just subtract 1, great, so we get negative 2x is less than 6, and then divide by negative 2, except, oh, this is that super important divide by a negative. So we have to switch the sign's direction. It's now pointing the other direction. You say y, and we'll talk about y. And this becomes x and negative 3. And there's your answer. Okay? So, I'm going to talk about y in a couple different ways because this is important to understand. You know, maybe people would be like, just do more examples, just examples. In my head, I'm like, the big picture is so much more beautiful, more important. So, y, okay? Well, first, you can avoid this. Okay? So when we're rearranging things, putting all the variables on one side, all the numbers on the other, you can just always put the variables on the positive side. So you never divide by anything. Right? We can absolutely do that. and there's no reason you would ever multiply by a negative. So yeah, it's just this last step, do you divide by a negative? But if we just put the 2x's over here, and the 6 over here, then the 6 is negative and the 2x is positive. And we divide by positive 2. So just to do this exact same example, we get negative 2x plus 1 is equal to 7. Whoops, last time. Okay. So what I'm going to do is instead of putting the numbers on the right, I'm going to put the x's on the right. Okay, so I'm going to go plus 2x plus 2x. Okay, so I get 1 is less than 7 plus 2x. Subtract 7, subtract 7. I get negative 6 is less than 2x. And see, just by moving them to the other side, now I'm dividing by positive 2. So you never have to remember that. And I don't remember it. I always move the things to the positive side. I shouldn't say I don't remember it. I do remember it, I just don't use it. Okay? And you get the same thing both times, even though it looks backwards. Over here, it's x is larger, greater than negative 3. Here, same thing. X is the bigger side. X is larger than negative 3. So you get the same answer, and you never have to remember that divide by a negative. Okay, but really quickly, the y, which, you know, I always think about this y, while the teacher's talking in my head, I'm like, I wonder why. Okay, so here's the reason. And you don't need to write this down, this is just to share with you. Okay, I always think about it vertically. So I think about it as two race cars in the equation, okay? One side is greater than the other side, okay? If I add a number to both sides, like say add 2 to both sides, both move up 2, okay? So the one on top is always greater than the other. If I add 3 to both sides, the one on top stays on top. If I subtract 5 from both sides, the side that was greater stays greater because they're always moving up or down the same amount, okay? All right, that makes sense. What if I multiply both sides? Okay, well if I multiply both sides by 2, the number that was greater, double that number is definitely greater than double the smaller number. Even if they're on opposite sides, double them, they just get further to 0. This car on top is always on top. Even down here the negatives, double negative 5, negative 10. Double negative 2 or 3, negative 6. Right? So this car on top is always on top, except what happens when you multiply by a negative? Think about it in English. In English, the word for multiply is of, and negative is opposite. So the opposite of makes sense that the opposite of it is you flip it. But look, if you have something at negative 6, or in positive 6, and something at 3, and you multiply by negative 1, you were literally saying the opposite of this result is 6 goes to negative 6, and 3 goes to negative 3. Now you've switched the results of the race, because whatever one was on top, when you multiply by a negative, whatever was highest up is now highest down, and whatever was not as high up is not as far down. So that's why when you multiply by a negative, it switches the results of which one's on top, because whichever one was 100 is now negative 100. Okay, so that's why, if you were curious, it's not an arbitrary thing. When you multiply by a negative or divide by a negative, you're literally saying the opposite of it. So whichever one was bigger, 5 is bigger than 3, now negative 5 is lower than negative 3. So that's why we switch it. All right, so we got 3 ways to write an inequality, and then we'll just do some examples. Okay, the first way is as an inequality. Okay, so after you solve an equation, you'll get a result that's in the form of an inequality. So it'll look like x is less than negative 2, x is greater than or equal to 1, and negative 5 is less than x is less than or equal to 0. And I'm going to use these same 3 examples and write them in the other 2 ways That way you have 3 examples that have already been written in 3 different ways. Okay, number 2 is as a graph, on the number line. Okay, and so for as a graph on the number line, you basically just need 2 pieces of information. Okay? For this it's, okay. Yeah, we'll get there. Okay. Okay, so it's an end value and an arrow indicating direction, and the end value can either be open or closed. In other words, it can either be empty or filled in. Okay, and we're going to talk about what that means right now. A closed circle means you include the end value as an answer. Right, so this we use less than or equal to, greater than or equal to, or square brackets, which we'll talk about what that means in a second. And the other one is an open circle. Means you do not include the end value as an answer. Okay, so for this we use less than, greater than, or round parentheses. Okay, so let's do those same 3 examples. Okay, the first one is x is less than -2. So I'm just going to draw a number line. The key thing here being that a number line has equal intervals. Whatever interval is between 2 hash marks has to be the same interval between every hash mark. Usually 1, unless it's a fraction or something, then you need a different interval. Alright, so am I going to use an open circle or a closed circle for x is less than -2? I'm going to use open, because we're not including -2. -2 is not a solution. You can get as infinitely close as you want, but you can't include -2. And then which direction are we going? Yeah. What matters is x smaller than or greater than? X is smaller than, because that's the smaller side of this greater than or less than. So x is smaller, so the left. You would do it like that. Okay? The next example is x is greater than or equal to 1. So, we draw a number line with 1 somewhere on it. Again, equal intervals. And do we use an open circle or a closed circle?
Closed.
Closed circle, because we're including 1 as an answer. Our fence post is at 1, and our fence post is an answer. And then which side do we go? Yeah, what matters is x bigger or smaller? X is the bigger side. So do not think because the arrow points right, because the arrow points left, because I could rewrite this as this. Those are exactly the same and the arrow's pointing in different directions. So don't remember arrows pointing, that's a poor way to remember. Okay, what matters is x bigger or large or smaller? X is bigger, so we're going to the right. Okay, last one. same examples from the first part. So -5 is less than x is less than or equal to 0. So now it's sandwiched between two values. And we'll get to solving problems like this. But think of it now as you're in your yard, right? You have one fence on that side and one fence on that side, and this portion is your yard. So, drawing a number line that has a -5 and has a 0 somewhere. So 4, 3, 2, 1, and then keep the pattern going. So -4, -3, -2, -1, 1, -6. And so how would I draw that one?
Open circle on -5.
Yep.
Close circle on 0.
Yeah, and?
Away from each other.
Going to.
So it's greater than
Okay.
-5, and then less than this, how would you draw it?
The solid line.
Exactly, just connect the two. This arrow does not keep going past that. It has to be between the two fence posts. So you just, you connect them. I see people, you shade them, however you want to signify it. But the main thing is open, close, and connect. Okay? And there will be cases where it'll be pointed away from each other. Alright? So that's the second way to write your answer. So every time you solve an inequality, I'm going to say represent it on the number line and represent it as an interval. Okay, now that you've seen it on a graph, the interval isn't as hard, but it is a new notation. So this is usually the one people get docked points on the test, which is sad. But all it is square brackets to be equals to, round brackets to be not equals to. That's it. But the hard part is you have infinity in there, and that's it. Alright? So, out on the right is, the third way to do it is an interval notation. Right, interval notation uses round parentheses and square brackets to show intervals. And there's just a couple things you need to know. So one is, this means they include the answer. We use this with less than or equal to, greater than or equal to, and a solid dot. Right, these all go together. Round parentheses means we don't include the answer. And we use it with less than, greater than, and open circle. Okay, and then two final notes. We write our two numbers of the integral in increasing order. So you would never write 5, 2. You would always do 2, 5, just like our number line always goes from negatives to positives. It never switches direction or switches order. And finally, the last little note. The last little note is positive or negative infinity. And that's the end, I'll just do some examples. So, those same 3 examples, the way we would write it is, x is less than -2 would look like this. Okay, so here's our fence post. We are not including it, and we are going on forever in that direction. Okay, so this, and this graph are exactly equivalent, okay? This, and this are exactly equivalent. They're like 3 different languages, yeah?
Do you have to put infinity first?
Yeah, because it's negative infinity, so it means it goes on forever less, and that's left. And that's what I was saying, we always do increasing order. Yeah, so negative infinity would go first. But if it was going from -2 that way, then we would write it second. Yeah, it's a good question. Okay, the other example was x is greater than or equal to 1. We would include 1 and go on forever and ever and ever in the positive direction. And that's exactly equivalent to this. Alright, all 3 of those exactly equivalent, 3 different languages. And that's part of what's stressful about this section, is that notation. The solving of an inequality is really just section 2.3. It's at the end, being able to represent it at each of these 3, but that's probably the newest part for a lot of people. And then the last one is -5 is less than x is less than or equal to 0. We would have -5 not included, include 0, square parentheses. And that's exactly equivalent to -5, 0, 5. See how I can switch the intervals? As long as it's equal, I can go by 5. And I mean, we would go to the next one, 10, 15. It doesn't matter what interval you choose, so long as it's always equal. And so it would go from -5 not including to 0 including, and you would connect them. Okay, so those are exactly equivalent, 3 different ways to write 3 different answers. So there's not many like new things I can throw at you, because really it's just section 2.3. So let me do one nice example with you that's kind of got a lot going on. We'll throw it all together. Okay? Yeah, there you guys have been sitting for a while. So actually let's do 2 examples. So 22 is a nice easy one. X plus 1 is less than 6. Okay? So to solve it, subtract 1, we got x is less than 5, and now we need to write it in the other 2 notations. So how can we write that in either notation?
Open circle.
Yeah, so we're gonna do at 5, open circle, and then let's put some other numbers here. Doesn't matter, as long as you have at least 3 numbers and equal intervals, you're okay. And then?
So, going to the left.
Yeah, because x is less than teeny side, so we're going to the left. And then how will we write an interval notation?
Parentheses, infinity, 5 infinity, negative infinity.
Negative. We start way off to the left, negative 8, and then?
5.
Yeah. And open, right? And that's it. So we have 3 different ways to represent the answer, all exactly equivalent. Okay, let's do one more, like, let's do 74. So 74 is 4, x plus 1 plus 2 greater than or equal to 3x plus 6. Alright, so it's just section 2.3. No new stress, it's only at the very end you have to turn it into other representations. So how would we solve it?
Distribute.
Yeah, distribute. 4x plus 4 plus 2 greater than or equal to 3x plus 6. Okay,
Combine like terms?
combine like terms. So we've got plus 4 plus 6 is 4x plus 6 is greater than or equal to 3x plus 6.
Subtract this six.
Yeah, I would do the x's first just because I don't want to get your, it doesn't matter, you absolutely need one. I'm gonna move everything to the side where there's more, so subtract 3x, subtract 3x, okay? So we have x plus 6 is greater than or equal to 6, and then,
Subtract.
yeah, subtract 6, subtract 6. We got x is greater than or equal to 0, we're done, and then,
Number line.
yeah, so we got a closed circle on the number line at 0.
You use the square brackets, right? This number
Well, let's
is-
do, wait, first we gotta do the arrow, and then,
Goes to the right.
so, closed circle going to the right, because greater than, and again, don't just say because the arrow's pointing right, that's not it. And then last one, I heard square parentheses at 0, which way?
Infinity's on the right.
Yeah, infinity's on the right, so comma, positive infinity on the right. And we never include infinity, so we always have a round parentheses there. And so that would be it. Those would be the 3 ways you would write that answer. The one thing I said, so Nick, the reason I said I don't subtract 6 first is because what happens is you subtract 6 first, and what you get is 4x is greater than or equal to 3x, which, totally normal problem, right? Except, what do people want to do there?
Divide.
They want to divide by something, they divide by 3, divide by, and what happens is they divide by x, and they get 4 is greater than 3, and then they don't know what to do. It's much better to, I'd say, subtract x's first, because it's a normal, like, once you get to here, the way you solve it is just like any other problem, you move the variables to one side, you should just subtract 3x, but people panic when they see that. And so it should just be x is greater than or equal to 0, that's not a problem, but for some reason when people see that, it's this is different, you know, but it's not. Just all the variables to one side, numbers the other. If the numbers cancel, that's okay, you're left with 0, that's totally fine, don't be scared of 0, but just, that's why I always do the variables first, so I know the variables cancel out, then it's all solution, no solution. Interestingly, I don't know if it comes up in this section, but it might, let's see. It does, wow, let's do one more. This is beautiful. Beautiful. Alright. Well, what if you were to have a problem like 82? 3x minus 5 is less than 3x minus 2. Okay? So, solve it like normal. What do?
Distribute.
Yeah, we distribute. We got 3x minus 5 is less than 3x minus 6, and then, yeah, subtract 3x. So everything's normal, do. Whoa, what are we left with?
Negative 5.
Less than -2.
Yeah, and so whenever all the variables disappear, what do we know? At any time, it's totally normal, this happens all the time, when all the variables cancel out,
No solution?
it's either no solution or
True for auto numbers.
all real numbers, because it's either always false or always true. So this one, let's be careful, let's think about it, you know, like this, here's 0, here's -1, -2, -3, -4, -5, -6. So is -5 less than -6? No, so this is always false, so the answer would be,
No solution.
yeah, no solution. And you don't need to graph no solution, you don't need to write no solution in interval notation, you can just write no solution. Okay, so that also happens, every time we introduce a new type of equation, the variables can always cancel out. And when the variables cancel out, all that matters is it's either always true, so all real numbers, or always false, no solution. So yeah, that's a great example, that could come up.